Hello everyone. This is part 1 video on past year NEET questions from the chapter Thermodynamics. We'll start with a question that has come in the NEET 2019 paper. It's a straight question. In which of the following processes heat is neither absorbed nor released by the system? Which means the heat exchange delta Q should be equal to 0. Now, if you look at an adiabatic process, the assumption is the system will be surrounded by what we call as an adiabatic wall, and that would not allow the system to exchange the heat with the surroundings. So delta Q for the adiabatic process will be equal to 0. So correct answer for this is option C, which is the adiabatic process. Now in isochoric, isothermal, isobaric, in all these processes we can have either heat absorbed by the system or heat being released by the system. So all these other three processes we can have heat exchange possible. Only in the adiabatic, heat exchange will not be there, and delta Q will be 0 for the adiabatic process. We'll move on to the next question. This is a question that has come in the Odisha paper 2019. This is a question based on the Cp by Cv ratio. The value of gamma Cp by Cv for hydrogen. So here we need to keep one thing in mind, that the Cp by Cv or gamma value will depend upon the atomicity of the gas. It will depend upon the atomicity of the gas. Hydrogen means what? It is a diatomic, H2. Two atoms will be there in that hydrogen molecule. Helium means it is a monoatomic. All these noble gases, right, they will exist as single atoms. And another ideal diatomic X means this X is also diatomic, whose molecules are not rigid but have an additional vibrational mode. So we'll talk about what is this vibrational mode. Basically we have to find the gamma values for these three gases. Now if you look at the gamma, right, gamma value will depend upon the degrees of freedom, number of degrees of freedom for that particular gas molecules. The relation is gamma will be equal to F plus 2 by F or 1 plus 2 by F. I mean, the difference is, we have just split this term, that's it. Okay, so where F will be the number of degrees of freedom. So the number of degrees of freedom is something that is related to the internal energy of that gas molecules. So as per the principle of equipartition of energy, right, for every 1 degree of freedom, so for every 1 degree of freedom, the energy for that particle will be half times K into P, where K is the Boltzmann constant for one particle of the gas for a degree of freedom. For our 1 degree of freedom, it will be equal to what? Half into kT. So this is the result that will come from the principle of equipartition of energy. So if the number of degrees of freedom for that particle is F, then for that one particle, total internal energy will be equal to F into half kT. Simply, we have to multiply this with the number of degrees of freedom. Okay. Now from here only the relation for the gamma will actually be derived. So we are not going to get into the derivation of how this gamma will be F plus 2 by F or 1 plus 2 by F. We'll just take this as a result. Okay. So here we'll try to focus on how do we obtain the degrees of freedom for this monoatomic, diatomic, and this gas X which is talked about. See, degrees of freedom will be associated with what is the possible energy terms involved. Like if you look at any gas particle, whether it is a monoatomic or diatomic or triatomic, it will be having 3 translational degrees of freedom. So for any gas particle, the number of translational degrees of freedom, so that will be associated with splitting of the translation kinetic energy along the 3 mutually perpendicular directions, x-axis, y-axis, z-axis. So for any particle there will be 3 translational degrees of freedom. Now for the monoatomic, since the molecule is going to exist as one single atom, rotational degrees of freedom will not be there. So for the Monoatomic rotational degrees of freedom will not be there. For the diatomic, rotational degrees of freedom will be 2. Triatomic, if it is a linear means it will be still 2. Non-linear means it will be 3. So here also the rotational degrees of freedom will be associated with the rotational kinetic energy, one with respect to the x-axis, one with respect to y-axis, and other with respect to z-axis. For the polyatomic, right, linear means same, 2 will be the rotational. Non-linear means we will get 3. So this is about the translation and rotational degrees of freedom. Now the vibration, right, will be another form of energy that can be associated with the particles in a gas. So if you look at starting from the diatomic, so monoatomic, there will be no concept of vibration. So starting from the diatomic, if you take a diatomic molecule, they'll have some inter-particle distance. But at high temperatures, what would happen is these atoms in the diatomic, so this is a diatomic molecule. So the atoms in a diatomic molecule, they will start oscillating or vibrating with respect to their mean position. Means they would, it can be assumed like, we have a sort of a spring between them. So they will be oscillating between the mean positions. They will go far apart and then they will come closer. So there will be oscillations. For every one vibrational mode, so for the diatomic, there will be only one vibrational mode. For every one vibrational mode, because in oscillation chapter also we will study, we will associate the energy in terms of potential energy as well as kinetic energy. So that oscillational or vibrational potential energy term will be there, and then kinetic energy term will be there. So there will be 2 degrees of freedom. Okay, so for every vibrational mode there will be 2 degrees of freedom. Now we are here anyway discussing about only the diatomic gas X. For that only we have to talk about the vibrational degrees of freedom, because they are saying what, it will have vibrational mode. So for every one vibrational mode there will be 2 degrees of freedom that will come. We will also see once we complete the question, right, first we will complete the answer for this question, then we will see for the triatomic or general polyatomic, how do we calculate the number of vibrational modes. So here we'll just complete the question. So H2 means what? This is a diatomic. So diatomic, there will be 3 translational and 2 rotational. Totally the number of degrees of freedom will be 5. For helium, monoatomic, only translation will be there. So F value will be equal to 3. And for this gas X, which is diatomic and also having 1 vibrational mode, so there will be 3 translation, 2 rotational, and then 1 vibration mode will give 2 degrees of freedom. Totally it will be 7. So for the H2, the gamma value will be F plus 2 by F, right? Means what? 5 plus 2 by 5, which is 7 by 5. For helium, 3 plus 2 by 3, which is 5 by 3. And for this gas X, it will be what? 7 plus 2 divided by 7, which is 9 by 7. So we can check. Hydrogen, it should be what? 7 by 5. And helium, it should be 5 by 3. And X, it should be 9 by 7. So the correct answer for this is option A. Now from this gamma values, right, because we already have one more relation between Cp and Cv, that is Cp minus Cv is equal to R. So using that Cp minus Cv is equal to R, and the gamma value, gamma is Cp by Cv, we can calculate the respective Cp and Cv values. So for example, for the monoatomic, right, if you talk about the monoatomic, Cp by Cv is what? This is 5 by 3, and Cp minus Cv for any gas, it will be R. So by using these two relations, because Cp and Cv are the unknowns here, we can calculate what is the Cp and what is Cv. Cp will be coming as 5 by 2R, and Cv will be coming as what? 3 by 2R. This is for the monoatomic. If you look at the diatomic, like this hydrogen, what is it? Cp by Cv is equal to 7 by 5, and same Cp minus Cv is equal to R here also. So Cp will be 7 by 2R and Cv will be 5 by 2R. Like this we will be able to calculate what are the Cp and Cv values of the respective gases. Okay, so maybe in I think further questions we will be using these Cp and Cv values. So the moment we see a monoatomic gas means what is the Cp value? Monoatomic means Cp will be 5 by 2R, Cv will be 3 by 2R. Diatomic Cp will be 7 by 2R, Cv will be 5 by 2R. So we said we look at the vibrational modes. If you have a triatomic or polyatomic in general, the number of vibrational modes will be equal to 3n minus 5 if it is a linear molecule, and it will be 3n minus 6 if it is non-linear. So here also we'll have a difference in terms of linear and non-linear, and we are not going to get into how this empirical result has come, because we'll just take it because the deeper study of the vibrational modes anyway is a little bit beyond our purview. So we can just take these result, vibration and modes. This is not the degrees of freedom, because degrees of freedom means what? We have to multiply this with 2, because for every vibrational mode there will be 2 degrees of freedom. Okay, so this is about the question that has come in the Odisha paper NEET 2019. Now we'll move on to the question that has come in NEET 2018 paper. A sample of 0.1 grams of water, which is at 100 degrees centigrade, and normal pressure 1.013 into 10 power 5 Newton per meter square, requires 54 calories of heat energy to convert to steam at 100. Means it is requiring 54 calories of heat energy. So it will be absorbing 54 calories so that it will convert from water to steam. If the volume of the steam produced is 167.1 cc, then the change in the internal energy of the sample is. So we have to find what is the change in the internal energy of the sample. So here we know what is delta Q. What is delta Q? Because it is absorbing 54 calories, means if you want to convert this into SI unit means what? We have to multiply this with 4.18. So the delta Q will be 54 into 4.18 joules. This is the delta Q value. This much amount of heat is absorbed. Now if you try to understand what is happening in the process, right? So we have 0.1 grams of water. The volume of this will be very insignificant, because the liquid state volume will be insignificant when we compare it to the vapor state. Now once this much amount of heat is supplied, this water is fully converted into steam. So what is the volume of the steam? It is 167.1 cc. If you look at it, right, consider the density of water, liquid water, as what? 1 gram per cc, means this 0.1 grams will be actually equal to how much? 0.1 cc only. We can see this is very negligible in comparison to the volume of the steam. Okay, now this is like, there is an expansion that is happening, and this expansion is happening against the constant external pressure, which is the normal pressure. What is the value? 1.013 into 10 power 5 Newton per meter square, or pascals. So if the expansion is happening against a constant external pressure, W will be equal to what? P times delta V. Work done by the system will be P times delta V. Now P will be equal to 1.013 into 10 power 5. We are anyway considering everything in the SI system. Delta V, change in volume, means what? So we can take it almost like the volume of the vapor. Why? Because the volume of the original liquid is insignificant. So 167.1 cc is there. We have to convert this into SI unit. So into 10 power minus 6 will come. 1 cc will be 10 power minus 6 meter cube. Okay, so everything is in the SI system. So W will be coming in terms of joules. Okay, so what is it that we are asked to find here? We are asked to find what is the change in the internal energy. Change in internal energy means delta U. So from the first law of thermodynamics, right, delta U will be equal to what? Del Q minus W. Heat that is absorbed minus work done. So which is 54 into 4.18 minus 1.013 into 167.1 into 10 power minus 1. So here 10 power 5, we'll have a 10 power minus 1 remaining. This will be in terms of the joules. Okay, So if you simplify this, right, so 54 into 4.18, from that we have to subtract. So here 167.1 in 10 power minus 1 means we can write it as what, 16.71. So 1.013 into 16.71. So if you simplify it, right, we will get the answer close to 208.7 joules. So 54 into 4.18, that multiplication we have to do, and from there we have to subtract this 1.013 into 16.71. So approximately the answer will be 208.7 joules. So here the only thing is we are considering the liquid volume to be insignificant, and it is an expansion against a constant external pressure of 1.013 10 power 5 pascals. Next we have a question, again NEET 2018. The volume V of a monoatomic gas. So whenever they talk about the atomicity of the gases, we have to be careful. The volume V of a monoatomic gas varies with its temperature T as shown in the graph. So this is the graph between the volume and the temperature. What is this graph? It's actually a straight line. The graph will be a straight line. Okay. The ratio of work done by the gas to the heat absorbed by it when it is undergoing a change from state A to state B. So state A to state B means what? These are 2 points on that same straight line. When the volume temperature curve is a straight line, what will be the process? Because if you look at the relation, right, from the ideal gas equation, what is the relation? PV is equal to nRT. So if you look at V as the y coordinate, here the y coordinate is what? Volume. So V is equal to what? nR by P into T. So if you see the straight line passing through origin, means what? This nR by P is going to be a constant. It is like y is equal to mx. It is like what? Y is equal to mx. That is a straight line passing through origin. Means this should be a process where the pressure is constant. Means what? This process is actually a isobaric process. That is the first conclusion. So the moment we see that the volume temperature curve is a straight line passing through origin, means what we can conclude? The relation should be that in the process pressure must be constant. Pressure constant means what? It is an isobaric process. Isobaric process of a ideal gas, dq, small heat exchange, dq will be equal to ncp dt. For an isobaric process of an ideal gas, the dq value will be equal to what? ncp dt, where cp will be what? The specific heat capacity, molar specific heat capacity of the gas at constant pressure. And what will be the cp value? Since it is a monoatomic gas, the cp value will be 5 by 2r. Already in I think the first question or second question we have talked about it. So for the monoatomic, cp will be equal to 5 by 2r and cv will be equal to 3 by 2r. Okay, so at least for the monoatomic and diatomic, right, we must be able to remember them. So n into cp is what? 5 by 2r into dt. Okay, so this is the dq. So that is what is the heat absorbed by the particular gas in the corresponding process when it is changing the state from A to B, which is an isobaric process. Then we also have to find what is the work done by the gas. What will be the work done by the gas? Since it is an isobaric process, we will take it as what? Small work done. dW will be equal to PdV. dW will be equal to what? It will be equal to PdV. Okay. Overall work means we have to integrate it, but yeah. So small work done will be PdV. But if you look at the dq term, right? dq term is expressed in terms of the temperature change, but dW is in terms of the pressure and volume change. So we must convert this into the temperature change. How do we do it? We will go to the ideal gas equation. What is it? PV is equal to nRT. Pressure is a constant. So if you consider PdV, means what? Differentiate this. Left side we take a derivative, means it will be what? PdV will be equal to right side N is a constant, R is a constant. Only temperature is the one that will be variable. So PdV value will be nothing but NR dt, which means the dW can be also expressed as what? NR dt. Now they are asking us the ratio of work done by the gas, means this dW to the heat absorbed, means they are asking us dW by dQ. So dW is what? NR dt divided by dQ is what? N into 5 by 2 R into dt. So this dt is cancelled, R is also cancelled, N is also cancelled. 2 will go to the numerator. So the ratio will be what? 2 by 5. Correct answer is option A. We'll move on to the next question. This is a question based on the Carnot's engine. The efficiency of an ideal heat engine, means they're talking about the Carnot's engine. Okay, so the efficiency of an ideal heat engine working between freezing point and boiling point of water. Freezing point means what? 0. Boiling point means we'll take it as what? 100 degrees. So a Carnot engine, what is a Carnot engine? It's an ideal heat engine which will be consisting of 2 cycles. One isothermal, second is adiabatic. So there will be isothermal expansion, adiabatic expansion. Then there will be isothermal compression, adiabatic compression. So there will be 2 isothermal parts and 2 adiabatic parts in the ideal heat engine, which is the Carnot's engine. So this will be operating at the maximum efficiency, maximum possible efficiency between source and a sink. So here source will be the place from where the heat energy will be derived, using which the work will be performed. So if Q1 is the heat taken from the source, using which W is the work performed, the remaining amount of heat will be rejected to the sink. Sink will be at a low temperature. So let's say the temperature of sink is T2 in Kelvin scale. Temperature of source is T1 on Kelvin scale. Both the temperature must be on the Kelvin scale. Now the Carnot's efficiency will be given by 1 minus T2 by T1. So this is the maximum possible efficiency that we can achieve for any heat engine that operates between the corresponding source, which is at high temperature T1, and the sink, which is at a low temperature T2. So this is about the concept of the Carnot's engine. So here what are we supposed to find? We are supposed to find what is the efficiency of the ideal heat engine, means Carnot's engine working between freezing point. So here the freezing point will be representing what? That will be representing the sink, and boiling point of water represents what? Source, because freezing point is the low temperature and the boiling point is the high temperature. They need not have to tell us. By looking at the values itself, we must be able to conclude that. So here since we know that the efficiency is what? Carnot's efficiency will be 1 minus T2 by T1, where T2 is the temperature of the sink and T1 is the temperature of the source. So here the sink is what? Maintained at a temperature of freezing point. 0 means in terms of Kelvin 273. We can take it as 273.15 also, but let us take it as 273. Boiling point of water means what? 100 in terms of Celsius. It will be 373 on the Kelvin scale. So sink temperature T2 will be 273. Source temperature will be what? 373. Now the only thing is we have to just go and substitute. So here if you look at the options, right, they are giving the options in terms of not the eta. So eta is generally the fraction. Eta is what? The fraction. But they are giving the answers in terms of the percentage, means we have to multiply this by 100. So the efficiency in terms of percentage will be what? 1 minus T2 by T1 into 100. So fraction when we multiply it by 100, we will get the percentage. So we'll just have to substitute, that's it. So 1 minus 273 by 373, take an LCM, it will be what? 373 minus 273 by 373. So numerator will be already into 100 is there. So numerator will be what? 100, because 373 minus 273 will be 100. So 100 divided by 373 into another 100. If we simplify, means we will get the answer approximately as what? 26.8%. It's a very standard question. So if you are operating the Carnot's engine between the boiling point of water temperature and the freezing point of water. The Carnot's efficiency for that heat engine will be 26.8%. Next, we have a theoretical question. This is a question that has come in 2017 paper. Thermodynamic process are indicated in the following diagram. So they are giving us 4 processes. We have to match process 1, whether it is adiabatic or isobaric or isochoric or isothermal. Process 2. So we basically have to match. So if you look at process 1, so we'll just go one by one. Process 1 is what? This is the PV diagram, right? So process 1, look at it. Each and every point, it's a vertical line, means what? The volume will be constant. For each and every point on that vertical line means x coordinate will be constant, right? X coordinate means what? This one. So for each and every point, the x coordinate is constant, means volume is constant. Volume constant means what? It will be an isochoric process. So process 1, which is P, will be what? P is matched to C, isochoric. Now if you are solving this question in the final examination, right, we'll have to always keep an eye on the option, like, P should be matched to C, right? The moment we see it, option C cannot be the answer, option D also cannot be the answer. Why? Because only in A and B, P is matched to C. Okay, now look at 4. Why I am saying 1 and 4 is because these are one is the vertical line, other is an horizontal line. 4 is what? Horizontal. Horizontal line means what? The height or the pressure will be constant. So for the 4th, pressure is constant, means what? It must be isobaric. So process 4, which is S should be what? Isobaric, means S should be matched to B. So where is S matched to B? Only in option A. Only in option A we have S matched to B. Like that we will be able to quickly conclude what is the answer without even really required to go through all these matches, because obviously, that's the thing, right? So it will be able to save our time, and we will still be able to get our +4. So the correct answer is what? Option A. We can look at the others also. So what are the others that are there? 3. Look at 3. It is going along, 3 is going along a curve where we are giving a particular temperature. Means what is it? Temperature is maintained constant, means it must be an isothermal process. So 3 should be isothermal. Look at it. R is matched to D. Check it. In that option A, R is matched to D. Okay. So now if you are able to match 3 of them, means 4th is automatically matched. Okay. So 4th one is what? It is the process 2. Now process 2, frankly speaking, we will not be able to tell. So as per the matching, what is it coming as? It is coming as the adiabatic. See, process 2 can be any general process also, because see, this is the isothermal, and the process 2, I am comparing process 2 and 3. Process 3 is what? Isothermal. 2 is steeper. Process 2 is what? More steeper. It is falling down rapidly than the isothermal. So adiabatic will be a steeper curve than the isothermal. But we can also have general process called as polytropic process. So maybe I think we have one question on the polytropic process also. In polytropic processes also, we'll have the curve falling steeply in comparison to isothermal. So just by looking at the graph, we may not be able to straight away tell that okay, the process 2 is adiabatic. But since it is a match the following question, right, we already matched 3 of them. The 4th one will be indicating what? The process 2 will be an adiabatic. But keep this in mind that just because a curve is falling steeply than isothermal, it need not mean always it is an adiabatic. It can be a general polytropic process also. Okay. So this is about the question that has come in 2017. And correct answer for this is what? It is option A. Next we have another question that has come on the Carnot's engine. A Carnot engine having an efficiency of 1 by 10 as heat engine. What is the efficiency of this? It is 1 by 10. Is used as a refrigerator. Now if you understand the working of the heat engine and the refrigerator, they will be just inverse to each other. if the work done on the system is 10 joules, so this is the information about the refrigerator. Okay, so this is the information about the refrigerator. If the work done on the system is 10 joules, the amount of energy absorbed from the reservoir at low temperature is. So for that, what we need to do is we should look at what is the similarity we are talking between the heat engine and the refrigerator. So look at this. So we have a heat engine, means it will derive heat from the high temperature source. Okay, and it will do the work by using that heat. Not all heat can be used to do the work. So some amount of heat will be rejected to the sink. So sink is what? Low temperature, and source will be what? High temperature. So this is the heat engine working. Now let us look at the refrigerator. If you look at the refrigerator, it will be just inverse of it. So we will see how it is going to work. In refrigerator will not do work. Actually, electrical work will be done on the refrigerator. So there will be work that is done on the refrigerator. We can see every process will be what? Reverse. So here we will take heat from the low temperature. We'll actually take heat from the low temperature. So Q2 will be also reversed. Now Q2 plus W will be Q1 based on the energy balance rate. Q2 plus W will be what? Q1. Here also you can see one interesting thing. Q1 will be equal to what? Q2 plus W. The total heat that we derived will be equal to what? The work done plus the heat that is rejected. Here also you see W, the electrical work done, plus heat taken from the low temperature will be equal to what? Heat given to the high temperature. So in case of refrigerator, we will take heat from the low temperature and give it to the high temperature. So we can see it is just the reverse. Now they are saying the Carnot engine is having an efficiency of 1 by 10. The efficiency of Carnot engine, right? So for a Carnot engine, efficiency will be what is the amount of work that we are able to do divided by the heat taken from the source Q1. So this is what is the efficiency, and this they are saying is what? 1 by 10. Now the same engine is as it is used in the reverse mode as a refrigerator. The same engine is as it is used in the reverse mode as the refrigerator. Means in the case of refrigerator also, what is this W by Q1 value? W by Q1 value is what? 1 by 10, because same setup is used. Okay, and they are saying if the work done on the system is 10 joules, means W they are saying is 10 joules. So take W 10 joules. Okay, so from here what we will get? Cross multiply. Q1 will come as what? 100 joules. Means the heat that we are giving to the high temperature side, which is usually the atmosphere, that is 100 joules. This is a 10. They are asking the amount of heat energy absorbed from the reservoir, which is at low temperature. So 10 joules is the work done. Total energy that is given to the surroundings is what? 100. Means from this side how much we should take from the low temperature reservoir? We should be taking 90. Then only 10 plus 90 will be what? 100, right? Because the same relation, W plus Q2 is equal to what? Q1. Means Q2 will be equal to what? Q1 minus W, that is 100 minus 10, which will be 90. Okay, so the correct answer for this is what? Option A, which is 90 joules. So we must be taking 90 joules from the low temperature reservoir in the case of the refrigerator. Okay, now for the heat engine we use this efficiency factor eta, which is W by Q1. So we are done with the question. For the refrigerator, right, we use something called as coefficient of performance, which is COP. Generally we will indicate this with the symbol beta. For the refrigerators, what is the performance of the refrigerator? It will be measured by using what? The coefficient of performance, which is generally indicated by the symbol beta. So coefficient of performance will be what is the heat we are able to derive from the reservoir per the electrical work that is done. So coefficient of performance will be what? It will be Q2 by W. So this is the coefficient of performance in the case of the refrigerator. For the heat engine we use the efficiency factor. For the refrigerator we use the coefficient of performance. In fact, if we say that the same heat engine is used in reverse as refrigerator, right? We can even look at what will be the relation between the beta and eta. So this is what eta, efficiency factor is eta, and coefficient of performance is what beta. So we can look at what will be the relation between the eta value and beta value. So what will be the relation? Beta will be equal to 1 minus eta by eta. So we can check how this comes, because this is an important one. Sometimes we have got questions on this in couple of medical entrance examinations. So beta will be equal to what? 1 minus eta by eta. So we can just show how this result will be satisfied by substitution itself. So 1 minus eta means what? W by Q1 divided by W by Q1. So take an LCM. Q1 minus W by Q1 divided by W by Q1. Q1 is cancelled. Q1 minus W by W. What is Q1 minus W means? Q2, right? So this is what? So beta will be equal to what? 1 minus eta by eta. Okay, so this is the relation that we can remember, so that if there is any question on that, right, we will be able to easily attempt it. We will go on to the next question. This is the question that has come in the NEET paper 2 of 2016. So this is a question based on the polytropic process. 1 mole of an ideal monoatomic gas. So what is it? Monoatomic gas undergoes a process described by the equation. So P into V power 3 is constant. See, PV is equal to constant means what? It is an isothermal. PV power gamma is equal to constant means what? It is an adiabatic process, where gamma will be Cp by Cv. But here what they are saying, and monoatomic means gamma is what? For a monoatomic, gamma will be 5 by 3. But here the relation is what? PV power 3 is equal to constant. So this relation, right, generally what we will represent it as, or we will call it as, is we will call it as a polytropic process. For this we have to find what is the heat capacity. So we have to find what is the heat capacity of the polytropic process. So we have a standard formula for that. If we have a polytropic process represented as P V power alpha is constant. So here alpha value will be equal to what? 3. Alpha value will be equal to 3. So for this the heat capacity will be Cv plus R by 1 minus alpha. The value will be what? Cv plus R by 1 minus alpha. So for a monoatomic means Cv will be what? It will be 3 by 2 R. Monoatomic Cv will be what? 3 by 2 R, right? So it will be what? 3 by 2 R plus R by 1 minus 3, which is what? 3 by 2 R. So 1 minus 3 means minus 2, minus R by 2, that is totally R. So the correct answer for this is option D, which is R. So this formula we have to keep in mind. What is it? The heat capacity for a general polytropic process, which is given by the relation P into V power alpha will be constant. So for that the heat capacity will be Cv plus R by 1 minus alpha. Next we have another question, NEET paper 2 of 2016, based on the refrigerator. So already we talked about the refrigerator concept. So what is the refrigerator concept? We'll have the electrical work done, and because of this we will be able to derive heat from the low temperature reservoir, and the total sum of work plus heat, which is Q1, will be rejected to the high temperature surroundings. This is what is the working of the refrigerator. The temperature inside the refrigerator is what? T2, and the room temperature is T1. Both are in terms of Celsius. So inside refrigerator means what? This is T2 in Celsius. Room temperature means that is the place where we reject high temperature, which is T1. Both are in Celsius. The amount of heat delivered to the room for each joule of electrical energy consumed, ideally. So what they are saying, in ideal case, which means we will have to look at the reverse of the Carnot's heat engine. In ideal case, they are asking us what? The amount of heat delivered to the room, which means they are asking us heat delivered to the room is what? Q1. Q1 by W they are asking. They are asking what is the Q1 by W. So amount of heat delivered to the room for each joule of electrical energy consumed. So Q1 by W value in ideal state means the reverse of Carnot's engine. So if you look at it, right, I mean the Q1 and Q2. So for the Carnot's efficiency, the ratio of Q1 by Q2 will be equal to what? It will be equal to T1 by T2. But temperatures must be on the Kelvin scale. So we are going to just use that relation. So Q1 by Q2 must be equal to what? It should be equal to capital T1 by capital T2. Capital T1 and capital T2 are what? They are the temperatures in the Kelvin scale. So what we are looking for? We are looking for this value Q1 by W. So first what we'll do is we'll look at the temperatures given to us. Inside the refrigerator is what? T2 Celsius. Room temperature is what? T1. Okay. So as per the ideal efficiency, the Carnot's efficiency, we must have Q1 by Q2 ratio should be equal to what? Capital T1 by capital T2. Means Q1 by Q2 will be small t1 plus 273 divided by small t2 plus 273, because we have to convert the Celsius temperatures into Kelvin. And what is this Q2 here? Q2, if you look at the relation, right, Q1 is equal to what? Q2 plus W, means Q1 minus W is equal to Q2. So in place of Q2, what we can express? Q1 minus W. Why are we doing it? Because remember, the ratio we are looking for is what? Q1 by W. We don't require Q2 here. Okay. So here if you see the denominator, we have Q1 minus W. So only when we reciprocate it, right? If we reciprocate it, means what we are going to get? We will get Q1 minus W by Q1. Q1 minus W by Q1 will be equal to what? T2 plus 273 by T1 plus 273. So we can split it. When we split it, what we are going to get? 1 minus W by Q1 is equal to what? T2 plus 273 by T1 plus 273. So we reverse it and then we split the numerator. Okay. So look at it, what we are going to get? We will be getting the 1 minus W by Q1. 1 minus W by Q1 is equal to what? T2 plus 273 divided by T1 plus 273. Okay. Now we are looking for Q1 by W, right? So first we will try to get W by Q1. So W by Q1 means what? We have to rearrange. So W by Q1 means what? We have to rearrange, right? So we have to take this to the right side and bring it to the left side. What we'll have? 1 minus T2 plus 273 by T1 plus 273 is equal to what? That will be equal to W by Q1. And if you take the LCM, it will be what? T1 plus 273 minus T2 minus 273 divided by T1 plus 273. Here 273, 273 is cancelled. What you have in the numerator? T1 minus T2. Denominator is what? T1 plus 273. That is our W by Q1. So W by Q1 will be equal to what? I mean, we are just rearranging the terms and then concluding the simplification by taking the LCM. So what we will get is W by Q1 will be equal to what? T1 minus T2 divided by T1 plus 273. But what we are looking for? Q1 by W. Q1 by W means what? Reverse of it. So Q1 by W will be equal to what? T1 plus 273 by T1 minus T2. So look for where we have the answer. T1 plus 273 divided by T1 minus T2. So the correct answer for this is option B. I mean, the only thing in this question is, we know ideal refrigerator will work as per the Carnot's efficiency principle. So Q1 by Q2 will be equal to capital T1 by T2. So from there we are just going on in getting the relation in terms of small t1, small t2, and then finally getting the Q1 by W, because here we are looking for what? The amount of heat delivered to the room for each joule of electrical energy consumed. So we are trying to do some mathematical simplification to get the answer. Okay. Now we will move on to the next question. This is a very interesting question. This has come in the NEET paper 1 of 2016. A gas is compressed isothermally to half its initial volume. The gas is compressed isothermally to half its initial volume. The same gas is compressed separately through an adiabatic process until its volume is again reduced to half. Means same phenomenon. We are compressing it on one side isothermal, so that the volume becomes what? Half. Other side we are compressing, so that the volume becomes half in adiabatic manner. So look at the options, right? What are the options? Compressing the gas in isothermal or adiabatic will require the same amount of work, because when you're compressing gas, we will be required to do the work on the system. Which of the case, whether the compression through isothermal or compression through adiabatic, requires more work will depend upon the atomicity of the gas. So all these options, if you look at, right, they are talking about how much work has to be done. Option C is what? Compressing the gas isothermally will require more work to be done. Okay. Option D is saying compressing the gas through adiabatic process will require more work to be done. So we have to find out which of them will be requiring more work to be done, or what is the situation. So if you look at the work to be done, right, we can arrive at the work to be done if you are able to represent the processes on the PV graph. Like if you are able to represent the process on the PV graph, right, we will be able to understand how we can see the relation in terms of the work. Now here we need to keep one thing in mind. So both of them will be starting from the same volume. Whether we talk about the isothermal or adiabatic, both of them will start from the same volume. Now remember, we have already talked about the relation between isothermal and adiabatic when it comes to the representation on the PV graph. Adiabatic will be more steeper. Isothermal will be gradual, adiabatic will be what? More steeper. Means what we will be having is, if you look at the graphs, right, so if say for example this is a graph, this is what? The isothermal. The adiabatic will be more steeper. Means what? The graph as such will look like it is falling more rapidly. That is what you mean by say by steeper, right? So it will look like this. So it will be more steeper. This is what? The red one is the isothermal. The blue one is what? Adiabatic. So it will be more steeper. So this red one is what? Isothermal. It will be more gradual. Isothermal is going to be what? It is going to be more gradual. That is the isothermal. Adiabatic is going to be more steeper. Now the moment we are able to see this, right, so both of them will have the same final volume, which is V by 2. If you want to look at what is the work that is required, so how do we represent the work? Work is represented as what? The area below the graph. So you can see clearly, if I try to mark the area below that adiabatic, you are going to definitely get more amount of area, isn't it? Whereas if you mark the area below that isothermal, you will get only this much. This is the one, that is the area below the isothermal. So what is the conclusion? The adiabatic will be requiring more amount of work to be done. So compressing the gas through the adiabatic process will be requiring more amount of work to be done. The same, we can also look at it like this. So starting from the volume V1, V2 will be equal to what? V1 by 2. We see that the adiabatic will be what? More steeper. Isothermal is what? This is isothermal, gradual. Adiabatic will be steeper. So the one that is more steep is what? This is the adiabatic. Gradual one is the isothermal. We can see that adiabatic will be required to do more work because the area below the graph is more. So compressing the gas through the adiabatic process will require more work to be done. So the correct answer is what? Option D. So this is about the part 1 video, and we'll see in the next part.